Good morning everyone. Today we are going to start the new online classes, and today's our topic is second law of thermodynamics, which is in the subject chemistry 2. Subject code is 02CY0151. It contains process, spontaneous process, non-spontaneous process, criteria of spontaneity, statement of second law, cyclic process, the Carnot cycle, heat engine, efficiency of heat engine. There are 4 different operations: first operation, second operation, third operation, and fourth operation. First operation is isothermal reversible expansion, adiabatic reversible expansion, isothermal reversible compression, adiabatic reversible compression. Other contents are net heat absorbed in one cycle, calculation of thermodynamic efficiency, Carnot theorem, entropy change in an irreversible process, the Clapeyron equation, Clausius-Clapeyron equation, and several numericals. So we are going to learn all the contents and all the definition and all the theorem in this unit. So first we will go for the introduction. It contains the first law of thermodynamics. First law of the thermodynamics says that the energy cannot be converted, it can be transferred from one form to another form. It cannot be converted or destroyed. So first law of the thermodynamics states that the one form of the energy can change into another form, but the total amount of energy remains the same. So once we specify a particular process of change, this law helps us to balance the internal energy, heat release and work done in the process. But the first law of the thermodynamics does not help to find out the direction of the process. Which direction is reaction is going, whether it is spontaneous, it is non-spontaneous, quick or slow. So to understand the direction of the reaction, we have to understand the second law of the thermodynamics. So before going to learn the second law of the thermodynamics, we learn the basic terms, several terms which will be useful to understand the phenomena of second law of thermodynamics. So what is kinetic? You know what is kinetic? Kinetic is a branch of chemistry which concerns the study of rate of reaction. So wherever the rate of reaction involved, it comes under the branch of the chemistry which is known as the kinetic. Kinetics means the rate of the reaction. How fast, how spontaneous the rate, how fast the reactants are converted to the products, it comes under the kinetics. Second term is thermodynamics. Thermodynamics is also one of the branch of the physical chemistry which deals the relationship between the heat and energy. So wherever the heat and energy is involved, there is a thermodynamic study is there. So you can study the heat and its energy equations by means of the thermodynamics. So what is process? The first term is the process, basic term. Process is a phenomena which related with the energy and work. So wherever the energy is involved or work is involved, it is known as the spontaneous process. There are 2 different type of process: spontaneous process and the non-spontaneous process. So in the spontaneous process, it means it's a quick process. It is a one direction process, a process which proceed of its own accord without any outside assistance. It can be happen naturally, like a process which happens naturally by its own. There is no need of external field to apply or external pressure or heat or anything to apply. The process happen naturally. It is known as the spontaneous process, like melting of ice. If you put an ice cube and it's automatically melt to the water, so it is known as the spontaneous process. It is irreversible. So ice cube converted to water, water cannot be converted to ice cube naturally. Similarly, hot water converted to the cold water. If you put hot water in the environment, in the surrounding, the hot water automatically convert to the cold water. This is the natural process and it is known as the spontaneous process. But cold water cannot be converted to hot water, because to convert cold water to hot water, you need a certain energy you require. So in general tendency, the process occurs naturally is called as a spontaneous process or spontaneity. So spontaneous process is known as the The process, reverse process which does not proceed its own, it is known as the non-spontaneous process. The process in which it cannot be like reverse process is where energy is required or heat is required, that processes are known as the non-spontaneous process. The reverse process which does not proceed its own. So the process which does not proceed by its own, you require certain energy or work to apply to continue that process are known as the non-spontaneous process. Like example of the spontaneous process, cliff jumping and mountain climbing. There are two different examples. By cliff jumping, jumping from the cliff or mountain, it is a spontaneous process. It is not a reversible process. You jump from the cliff and you cannot go back to the cliff. While the mountain climbing requires work, you need energy to climb the mountain. So these are the two different process that is known as the spontaneous process. There are two different process, climbing of the mountain or jumping of the cliff. So in the jumping of the cliff, it is a spontaneous process, while climbing a mountain it requires a work or energy to climb the mountain. Another term is the heat flow. When two metal balls, one is hot and one is cold, you connect both the ball. So spontaneously hot ball simultaneously transfer the heat from the hot ball to the cold one. So this is known as the spontaneous process. When two balls of metal, one hot and one cold, are connected with each other spontaneously from hot ball to cold ball, the heat transfer from hot ball to cold ball. Similarly, gas flow. If you see, one vessel is fully filled with the gas and one is the empty vessel. So gas molecule will transfer from the filled bowl or filled vessel to the empty vessel. This is a spontaneous process. From empty vessel, gas cannot transfer to the filled bowl or filled vessel. So this is a one direction process, both, whether it is heat flow or it is a gas flow. So these are the processes are known as a spontaneous process, and it includes the heat flow, gas flow, energy flow, or any other kind of element involves that is going to the one direction. This kind of processes are known as the spontaneous process. What are the criteria which leads to the spontaneity? So some important criteria as involved, there are physical and chemical change which involves in the spontaneous process. So first criteria is spontaneous change. What is spontaneous change? A spontaneous change is one way or unidirectional. It is always a one way or it is a one directional. It is not a reversible. For reverse change you require work or you have to give some energy. So most of the spontaneous process are one direction or one way or unidirectional. Another criteria is the change time. There is no factor of time. For a spontaneous change, there is no time factor. A spontaneous reaction occurs within a fraction of second, or it will take little bit time, but there is no time factor or a unit of time to measure the spontaneous reaction. Third criteria is if the system is in equilibrium state, then spontaneous reaction will not follow. If the system is in equilibrium, the spontaneous reaction will not follow. Means if there is a unequilibrium, one vessel is completely filled and one vessel is entirely empty, then system is in inequilibrium, then the spontaneous reaction will happen. So from one vessel to another vessel, gas will transfer, or one bowl to another bowl, the heat will transfer. So these are the various factors they are affecting the spontaneous reaction. The first is it is one directional, second is there is no time limit, third is if the system is in non-equilibrium, then the phenomena of spontaneous reaction takes place. If the system is in equilibrium, the phenomena of spontaneous reaction will not happen. The fifth term is the spontaneous change acquired in the internal energy, right? Or enthalpy, you can say. It implies that only such reaction will occur which is exothermic. So if you see, the most of the spontaneous reaction are exothermic. It releases the heat during this phenomena. If hot bowl is placed with a cold bowl, so energy from hot bowl will transfer to the cold bowl. So there is a release of the energy, or it is known as the exothermic reaction. If you see the melting of the ice or evaporation of the water, So it implies that only such reaction will occur which are exothermic. It implies that only such reaction will occur which are exothermic, but the melting of ice and evaporation of the rainwater are endothermic process which proceed spontaneously. There are several reactions that are endothermic as well. That is also known as the spontaneous reaction, like evaporation of the rainwater, that is or melting of the ice. There are the endothermic reaction. So clearly there are some factors in the addition, that enthalpy, that is delta H, which governs the spontaneity or the spontaneous reaction. It is the second law of thermodynamics which introduced this new factor that is called as entropy. Entropy is known as the randomness. So when gaseous molecule from the full vessel to the empty vessel, so there is a enhance in the entropy section. So whenever you go spontaneous, whenever the spontaneous reaction happens, the enhancements of entropy will increase. So the spontaneous reaction increase the entropy of the surrounding system. So what is entropy? Entropy is one kind of property, is a physical property of the thermodynamics. Enthalpy is equal to the sum of internal energy plus the product of the pressure and the volume of the system. So entropy is the one kind of property of the thermodynamics. It relates with the heat, pressure and the volume. So enthalpy is equal to the sum of internal energy plus the product of the pressure and the volume of the system. It is represented as H. H is equal to U plus PV, where H is the enthalpy, U is the internal energy of the system, P is the pressure and V is the volume of the system. Suppose there is a system we can consider as a conical flask, which is known as its system, and conical flask is hot in the nature. So if we place the conical flask in the surrounding, that is environment, so from it slowly start cooling. If the solution inside the conical flask is hot, so heat transfer to the surrounding, and it is an exothermic process, and it will try to maintain the temperature of the atmosphere, and at that level the system will become the equilibrium. So surrounding temperature and the system temperature will be similar. That time the system will be in the equilibrium, then there will be no heat transfer. Similarly, if in 1 RBF we put a cold water and surrounding there is a hot temperature around, so system will try to maintain equilibrium between system and surrounding. So cold water simultaneously become the warm water or the environment temperature water, and they will absorb the heat and it will become the cold water. So there are two different factors. One is the cold water, it absorbs the heat and it decreases their entropy and it will normalize to the normal temperature water. And another example is the hot water is there in the RBF conical flask. It will try to become a cold water, so it will release the heat and it will increase the entropy of the system. So there are two different factors. One factor is increasing the entropy. So when they release the heat, it increases the entropy. When they absorb the heat, it will decrease the entropy of the surrounding. So if suppose the ice cube is there, so all water molecules are well arranged. So there is no entropy, there is no randomness. Entropy is basically a randomness. There is a randomness in the system. But when the ice cube is melt and it becomes the water, so there is a water molecules are randomly freely moving around the system. It is like flowing. So there is a more randomness in the system. So whenever the system is going to the spontaneous reaction from the ice cube to the water, it will increase the entropy of the surrounding. So all the spontaneous reaction increase the entropy of the surrounding system at the end. Another term is the entropy. What is the entropy? Definition of entropy. For many years, scientists believe that only exothermic change resulting in the lowering of the internal energy of the enthalpy. It is known as the enthalpy. So any reaction is going, exothermic reaction is going, it will change the internal energy. Some system have their energy. Whether it will absorb the energy or further release the energy at the end of the spontaneous reaction. So at that time their internal energy will automatically decrease. Suppose you take the example of the ice. So if the ice cube is melted due to the endothermic reaction, it is a spontaneous reaction. In the same way, on the warm day, ice melt by itself. So it is like releasing the energy and it will become the water from the ice cube. So their internal energy will reduce. Same way the evaporation of the water is the example of the spontaneous reaction. It is a exothermic reaction, endothermic reaction. It will absorb the energy and it will convert it to the water. So we don't know whether it will absorb the energy or it will release the energy in the spontaneous reaction. So we have to learn the term like randomness in the system. So then the term come, entropy term come, that is known as the S. It is represented by S. So what is, first we will understand what is spontaneity and what is randomness. So if you see the careful example, so that each process like such as melting of the ice cube or evaporation of water, there is an increase in the randomness or disorder of the system. So if you melt the ice cubes are well arranged, water molecules are well arranged in the cube formation. But if it becomes the water, so there is a more randomness in the water molecules compared to the ice cube, or disorder of the system. You can say there is a disorder, there is no order in the, earlier the ice cube all the water molecules are organized in the manner, while it becomes the water, randomness or disorderness will increase. Same way the water molecules in the ice are well arranged and highly organized in the crystal patterns, which permits little movement, so there is no movement. But when the ice molecules melt or become disorganized and can move freely, it can easily move, the movement of molecules become free. Still when the water evaporates in the space, same way water is placed in the one vessel, if it evaporates in the space, so water molecules, the water vapor will roam around the surrounding. So there is a more randomness or disorder in the system. So we can say that the randomness of the water molecule increases as ice melts into water or water evaporates into the space. So whenever the spontaneous reaction goes, the randomness will increase. So then there is a term come entropy. Entropy is a thermodynamic state or a term which measures the randomness or disorder of the system. So whenever the disorder or randomness happens, it is measured by the entropy. The symbol of entropy is S, while the change in disorder accompanying a process from the start to completion, that is represented by its difference, that is known as delta S. So delta S is equal to final entropy minus the initial entropy. So if you know that the ice cube is there, that the initial entropy is always less, and when its ice burst is melt, it becomes the water, there is a more randomness. So S final, the entropy of the final compound is always greater than the entropy of the initial compound, and the change in the entropy is represented by delta S, and the equation is given as delta S is equal to S final minus S initial. So these are the basic terms, and these terms are really useful to understand the thermodynamics and its second law of thermodynamics. So if you see, if you play the cards, initially the cards are really well arranged. So there is no randomness. Cards are arranged like A, 1, 2, 3, 4, 5 to K. So A and like K and K all are very well arranged. But after playing, if you see, the cards are not organized. So there is a randomness after the, so A is the example of the initial entropy, there is no randomness, and B is the example of the randomness. The cards are random after the reaction. Similar example, if you say it's state A and state B. State A, there are all the molecules green and orange are organized very well. Suppose this is the example of the ice cube. So all the water molecule are well organized in the crystal form. But when it becomes the water, like ice cube is melt, so it becomes the state B. So there is a disorder. Hydro OH and H ions are randomly organized. They are not in the crystal form. So there is a more, you can say, randomness. More randomness means more entropy. So higher the entropy. So earlier there is a less entropy. and there is a high entropy. So a process accompanied by the increase in entropy, it is known as the spontaneous. So it tends to be spontaneous. So spontaneous process generally increase the entropy of the surrounding system. So suppose we take the examples. Let us consider the example of the molecule stated here is one is state A and state B. So in the state A, all the molecules are arranged highly in order. So all molecules are organized or arranged in the order. And if you see the example of the B, that is state B, molecules are organized, but that is in randomly organized. So there is less organization and there is no particular order. So there is a, if you say state A is highly ordered, low entropy, and these possibilities are, this kind of possible compounds are very less. And state B is highly disordered. So when the highly disordered or randomness comes, the higher the entropy and the higher the probability of that compound. So what we get from this image is, we can get the 3 points from this image is, the entropy of the state A is low that compared to the entropy of state B. Thus we can say the increase of entropy occurs in from change from compound A to compound B. According to the law of the change or the probability, A is less probable. So you can say more organized compounds are less, so there is a less probability of the compound A or state A compared to the probability of the compound B. Another is there, the change, whenever the state A changes to the state B, it will increase the entropy of the system. And when the entropy of the system is increased, it is known as the spontaneity or spontaneous reactions. So hence we can say that the change in the system which is accompanied by the increase in the entropy tends to be spontaneous. So these are the reaction of the spontaneous. What is the spontaneous reaction? So now we will go for the statement of the second law of the thermodynamics. So basically this unit includes the second law of the thermodynamics. What is the statement of thermodynamics and what is the how it is correlate with the entropy. So basically we have learned the different processes like kinetics, thermodynamics, process, spontaneous process, non-spontaneous process, entropy and enthalpy. These all terms are useful to understand the further phenomena of the second law of the thermodynamics. So first law of the thermodynamics says that energy cannot be created or destroyed. It can be only transferred from one form to the another form. That is the first law of the thermodynamics. What is the second law of the thermodynamics? Second law of the thermodynamics stated that whenever the spontaneous process takes place, it is accompanied by increasing the total energy of the universe. So it only says that whenever the spontaneous process happens, the energy of the universe will increase. Suppose you take the example of the ice cube. Ice cube melts to the water. It will like increase the energy of the universe. It is basically increasing the energy of the universe, or you can see it is increasing the entropy of the surrounding system. So more specifically we will understand, we take the universe, we will take the example of the delta S. So delta S is the difference in the entropy. Entropy is represented by S and the difference is represented by delta S. So delta S universe is equal to delta S system plus delta S surround. System is the reaction vessel. Suppose we take the RBF or a conical flask, it is inside material is system and surrounding area is known as the surrounding. The atmosphere is known as the surround. So system plus surrounding is known as the universe. So as per the second law of the thermodynamics tell us that when irreversible spontaneous process, the most of the spontaneous process are irreversible. It cannot be like converted from water to the ice cube naturally. So most of the spontaneous process are irreversible process and the entropy of the system and surrounding will increase. So whenever the ice cube melts to the water, the entropy of the surrounding will increase, more randomness in the surrounding. Similarly, when ice cubes start melting, so there is a increase in the system also, the entropy increase in the system also. Earlier the ice cube are well organized in the system. Once you start like melting water, so there is a increasing the entropy in the system as well as the surrounding. So you can say in another word, there is a always entropy of the universe is always greater than zero, because there are several molecules are moving around randomly in this universe. So you can say the entropy of the universe is always greater than zero. When a reversible process occurs, the entropy of the system remains constant. Like suppose reversible processes occur, so once the natural process occur, ice melt to the water, and water is converted to the ice group. That time there is a balance between the entropy. Once the entropy is increasing in the surrounding, and when it is converted to the reversible reaction, the entropy of the surrounding will be reduced. So entropy of the universe will be zero. When it will occur? When there is a reversible process, is natural process and the same process is reversed. So that time only the entropy of the system remains the constant. So you can say delta S. Here there is one mistake. Instead of delta universe, there is a delta system, delta S system. So delta S system is zero that time only. Once it is increased, when it is decreased, so that time in the reversible process, delta S system is equal to zero. Since the entire universe is undergoing the spontaneous change, the second law of thermodynamics is more useful, and it is related with the entropy of system is constantly increased. So second law of the thermodynamics stated that the entropy of the system or surrounding or universe will constantly increase due to the spontaneous process. So in the next lecture we will carry forward the another unit in the second law of the thermodynamics. Just you go through the presentation and the YouTube video, and if you have any doubts, just you can comment in the comment box, or you can directly message me. Just I will also upload the similar PPT in your portal, so you can download the PPT and just you go through it. In the next lecture I will continue from the same point, and then we will carry forward for the another topics of the same unit. So just if you have any doubt, just comment it, and just you can inform me. I will just solve your queries. Thank you.